In this video, we'll see how to compute the volume of a parallelepiped in 3 dimensions by using determinants. So here's our theorem. It's just the 3-dimensional analog to the theorem that we saw in 2 dimensions about computing the area of a parallelogram by using the determinant. So this theorem says that the volume of the parallelepiped determined by the 3-dimensional vectors u, v, and w is equal to the absolute value of the determinant of the matrix that has those 3 vectors as its columns. So let's see a couple of examples. So we'll take u equal to 2, 1, 1, v equal to 1, 0, 2, and w equal to minus 3, 1, 1. Now the picture of these 3 vectors in 3-dimensional space looks like this. Those 3 pink edges that you see are these vectors. And the parallelepiped that's determined by them is the one where we take each of these vectors and write a parallel version of it to make 2 rectangles, and then 3 rectangles, and then connect, and then do the same thing, kind of leveled up, to get all the different sides of the parallelepiped. The volume of this parallelepiped is equal to the absolute value of the determinant of that corresponding matrix. And so here I just note about the notation, I'm using those straight bars on the side of these 3 columns of numbers to indicate taking the determinant, and then another set of straight bars to say take the absolute value of it. So this is kind of, the straight bars are kind of an overloaded operator, and it depends on, what the inputs are as how to interpret it. If I compute the absolute value of the determinant of this, I'll get 10, and you should go through the computation and check that you do too. And it's a pretty straightforward computation, so it's, just a nice exercise to try it. One more example I want to show you because it's kind of an interesting case. So this time let's look at these 3 vectors. And the picture of these 3 vectors looks like this. These 3 vectors all lie on the same plane. So the volume of the parallelepiped that they determined should be 0 because there really is no parallelepiped. It's just flat. Let's check to see what happens with the determinant if we do actually get 0. Yep, we do. So when the 3 vectors are coplanar, the determinant will be 0. So next up, we'll have a summary about all these things that the determinant can tell us, and it's really impressive.